Welcome back again, pre-calculus. Our objective today is going to be to convert to and from polar and to rectangular again, but this time instead of just looking at points, we're going to be looking at actual equations before we get into graphing them. So I'm going to force a pause on your screen. Go ahead and double check the checklist for me. Alright, I'm going to force a pause on your screen. Before we get started here, can we do a little warm-up? Go ahead and write the point 3 comma pi over 4 and find me 3 additional polar representations for this point. So 3 more points that land in the same place that 3 comma pi over 4 lands. Alright, I've got 3 additional polar representations, so you can double check your work here. Go ahead and pause your screen and correct anything if you need to. Force a pause on your screen, just copy what I have and then we're going to fill this in together. Okay, so just a bit of a review. If we want to convert from polar to rectangular or vice versa, like let's say I give you r and theta and you want to find x and y. Well, to find x, you're going to do r times cosine of theta. To find y, you're going to do r times sine of theta, right? Now, if I want to go the other way around, if I have x and y and I want to find r and theta, then r is going to equal the square root of x squared plus y squared, and theta equals inverse tan of y over x. And again, we just have to be careful there, right, if we're using a calculator to calculate this for us, as opposed to looking right onto the unit circle, for example. All right, so these are some equivalencies that I want you to remember and kind of have handy as we continue today's lesson. Okay, so if we want to convert an equation from rectangular to polar form, it is pretty straightforward each time. We're going to make the substitution for x and y that you just wrote down, and then solve for r, okay? So will you please write this in your notes? X plus y equals 6, and we're going to convert to polar, and I'm going to show you how to check on Desmos, okay? So x was equal to r cosine of theta, plus y was equal to r sine of theta, right? And I have that is all equal to 6. Now I want to get r by itself. So what I want to do now is collect any terms that have an r in them on one side, everything else on the other. Well, that's already done for us, right? These two terms both have an r, a factor of r in them, and this one doesn't, it's on the other side. Once you've collected those terms, go ahead and factor out your r. So I've got r times the quantity cosine of theta plus sine of theta, and then on the right side I still have 6. And I'm almost there. To get r by itself, I would divide both sides by cosine of theta plus sine of theta, and that's our final answer. All right, let's check on Desmos. All right, so here's what we were given. X plus y equals 6. This is a line with y-intercept 6, slope of -1. Now I've also typed what we found, which was r equals 6 all over cosine theta plus sine theta. Now, by the way, if you want to get theta, you can just literally type in the letters T-H-E-T-A, and it turns it to theta, okay? Let's go ahead and highlight this, see if we get the same thing in blue. Yes, we do. So those are equivalent. And by the way, if you come over to the right for your tools, you can change your grid to be rectangular to polar. Okay, so that's the setting here, which just changes the grid for you. So again, if we want to convert an equation from rectangular to polar, just make that substitution that x is our cosine theta, y is our sine of theta. Get your r terms on one side so that you can factor that factor of r out and divide and get r by itself. Now if we want to go the other way around, if we want to take an equation that is in polar form and convert it to rectangular, we have to be a bit more creative. There's not just this like one way to do it in this case. So, but oftentimes you're going to start to see the convenience of polar. So let me ask you this. If I give you the equation, the polar equation r equals 5, what do you think the graph would look like? So r is always 5. Theta can be any angle. So that's going to be a circle centered at the origin with radius 5. So 1, 2, 3, 4, 5. It's going to draw it this way. Maybe. The graph is going to look something like that, right? Okay, so let's say I want to actually convert that equation. If you've just got r equals a number, go ahead and write r equals 5 in your notes for me. Let's go ahead and square both sides. So that would give me r squared equals 25, right? Now look at what we wrote for r. R is the square root of x squared plus y squared, right? So r squared would be just x squared plus y squared equals 25. That's our answer. And from our conic sections unit, we know that this is indeed a circle centered at the origin with radius what? Radius 5, right? But look at how much more elegant and simple this equation is versus our rectangular equation, right? So let me show you also on Desmos here. All right, so if I just type into Desmos r equals 5, Desmos can plot this polar graph for me. If I do this in rectangular form, let's double check, make sure the graphs are the same. They are indeed. And remember that we can change our grid to be polar. And you can see there that I am on a circle with radius 5 centered at the origin once again. All right, so the last example I gave you was just r equals a number. What if I give you just theta equals a number, like theta equals pi over 4? What do you think this graph is going to look like? So r can be anything, but theta must be pi over 4, right? So what do we think about this? Find my mouse here. So pi over 4, 45 degrees, right? So we've got kind of, looks like a line, maybe in quadrant 1, because r can be anything, but the angle has to be the same, right? Now, could this extend into quadrant 3? Like, could I do this? I could, right? Because r could be a negative as well. It just shoots our points across the origin. So do we know the equation of this line? This line is y equals x. Let's see if we can convert here. So here's what I'm going to do when I have just theta equals a number. I'm going to take tangent of both sides, okay? So I've got tangent of theta equals tangent of pi over 4. All right, well, look at what we wrote in our notes. We said that theta is equal to inverse tan of y over x. In other words, tan of theta is equal to y over x. Tangent of pi over 4, that would be root 2 over 2 over root 2 over 2. That's 1. So multiplying both sides by x, I do indeed get that y equals x. All right, so now just for fun, can you try to picture what the graph of this equation would look like, r equals theta? Any idea? So here's r equals theta. As r increases, as does your angle, as does theta, right? So you get a spiral, and this is a fun one, right? Such a simple equation gives a pretty cool graph. You can really play around with Desmos here. These are fun to do in like contrast mode. Now, what do you think would happen as I increased, if I put like a slider on theta? Like if I did this, can we go ahead? Some projector phone, yeah. So you can see you have kind of a twirling spiral. I could also graph r equals negative a theta. And now you've got, these spirals kind of moving as one. So you can create some really, really cool graphs with polar equations. I would highly recommend just kind of playing around with Desmos and seeing what you can come up with. All right, so we've looked at equations where I just give you r equals a number, in which case you would square both sides. We looked at where I just give you theta equals a number, in which case you want to take tangent of both sides. But what if you've got both r and theta in there? So write this example for me. R equals 3 cosine theta. What I'm going to recommend that you do here is multiply both sides by r. So r times r is going to be r squared. And then I'm going to put my r here, 3r cosine theta. Okay, now let's make some substitutions. What is r squared equal to? Well, r squared is equal to x squared plus y squared. Now, does this piece look familiar? R cosine of theta. That is x, right? So I've got 3x. And this is, I've now converted to rectangular form, right? But it does ask me to get this into standard form. So what we're going to do is bring that 3x over. I'm going to leave a little bit of space. I've got 0 on the other side. Any idea why I'm doing this? We're going to get this into standard form. So let's go ahead and complete the square. So my y's are good. I just have y squared here. Let's go ahead and complete the square for x squared minus 3x. So half of negative 3 is negative 3 over 2. Square that, I get positive 9 over 4. But what I do to one side, I have to do to the other. All right, so the x values factor into x minus 3 over 2 quantity squared plus, and then I just got y squared, equals 9 over 4, right? Okay, so thinking back to your conics, what is this shape? And this is going to be a circle centered at 3/2, 0 with a radius of 3 over 2. So let's double check. All right, so I have graphed what we were given, the original equation of 3 equals cosine theta. And now let's go ahead and look at what we got for rectangular form. Do we get the same thing in black as we did in purple? Yes, we do. And remember, you can change your grid to see, okay, yes, this is indeed a circle centered at 3/2, 0 with radius 3/2. All right, you all, I'm going to force a pause on your screen. Go ahead and copy what I have, and then we are going to summarize. Okay, so let's kind of put all those strategies into one chart here. So if I want to convert from rectangular to polar, then we're going to make the substitution of x equals r cosine theta, y equals r sine theta, factor out your r, so make sure anything that has an r is on one side, everything else on the other side of the equation, and then divide, in other words, solve for r. Okay, now if you're going from polar to rectangular, we had a few extra strategies here, right? So if you have only r's, like that example we had of r equals 5, what we're going to do is square both sides. Because this will always be a circle, right? And then we're going to sub that r squared is equal to x squared plus y squared. Now if I have only thetas, I'm going to take tan of both sides. And then we're going to sub in that tangent of theta is equal to y over x, and then on the other side we'd have tangent of some angle, and we can find that number from the unit circle. Now if we have a bit of both, like this last example we just did, what did we do? We multiplied both sides by r, right? And then we made that same substitution of r squared equals x squared plus y squared here, and then here we'll make a substitution that should yield an x or a y, okay? So a bit of both. We are going to multiply both sides by r, and then sub that x squared plus y squared equals r squared, and then as well as potentially one of those substitutions, okay? So practice these, kind of get a feel for them, and always, of course, feel free to check yourself on Desmos. All right, y'all, I'll see you next time.